Okay, so for number 11, we have that three real numbers x, y, and z are chosen between 0 and 1, with 0 being less than x, which is less than y, which is less than z, which is less than 1. We want to prove that the distance between two numbers, at least the distance between at least two numbers, is within 1/2 unit. So we're going to say let x, y, z be real numbers, and suppose 0 is less than x is less than y, which is less than z, which is less than 1. Okay, so it's saying, hey, the distance of at least a pair is 1/2, right? Within 1/2. So we're going to do this by contradiction. We're going to say, suppose no two numbers are within 1/2 unit. Let me rewrite this. Or within 1/2 unit from each other. So that is the opposite, right? We're supposing that, hey, none of these are within 1/2 unit from each other, which is the opposite of what we're trying to prove. So if none of them are within 1/2 unit, we have here z is greater than y, right? So we have here that z minus y has to be greater than or equal to 1/2. If none of them are within 1/2 unit, it means that it's either greater than or bigger. It's either equal to or bigger than 1/2. Okay. Same thing for we have that y is greater than x. So actually that should be y. So y minus x is going to be greater than or equal to 1/2. Okay. And I'm just going to label this equation 1 and equation 2. And we're going to say adding, actually I'll just say here, equation 1 plus equation 2 yields that z minus y plus y minus x is greater than or equal to, that's going to be 1/2 plus 1/2. So when we simplify this, we're going to get, let's see, z minus x is greater than or equal to 1, which implies that z is greater than or equal to 1 plus x. But x is greater than 0, right? So if x is greater than 0 and z is greater than 1 plus x, then it definitely means that z is greater than equal to 1, right? But we have that z is greater than or equal to 1 and z is less than 1, right? We said it here. We assumed that z was less than 1. So we have shown that a contradiction has happened, which is a contradiction. So it means that our assumption was wrong. So we're going to say, therefore, at least two of the numbers between x, y, z are within 1/2 units of each other, are within 1/2 units from each other. Okay, so we assumed the opposite. We showed that it leads to a contradiction, because that would mean that z would be equal to or greater than 1, but also z is less than 1. So our assumption must have been wrong, and therefore we proved what we wanted to prove. So that is it for item 11.